All right. So our question says the diagram shows a ray of light incident at a boundary between oil and water. The refractive index of water is 1.33. Which of the following expression gives the refractive index of the oil? So you have to figure out, Laiba, which of these will give you the refractive index of the oil. You have the refractive index of the water. So over here, write down my advice to you is whenever solving questions like these, always write down the data. Like this is available to me in the question. Okay. So what do you know from the question? You know that the refractive index of water is 1.33. You know that you have an angle in the water, angle in the oil, theta, when I'm writing theta. Angle in the oil is 15 degrees and angle in the water is 17 degrees. So you need to find the refractive index of oil. Now, all you have to do is apply one simple formula. That's it. I promise you, you just need to apply a formula and you'll get the answer. But you have to choose which formula to actually apply over here. So go through the formulas that we discussed and see if you can pick the correct formula that we can apply over here.
Do we use Snell's law?
Yes, use Snell's law. So use Snell's law and figure out the correct expression.
Miss, is it B?
The second one, Haja? Sorry, Laiba, second one?
Yeah.
Yes, the second one is correct. Good job. Okay, now next question that we have is which of the following describes threshold frequency? The frequency of light that causes photoelectrons to have maximum kinetic energy. The frequency of light emitted when excited electrons fall to ground state. What is ground state? Ground state is like, think of it this way, that the electrons, the natural state of the electrons is the ground state. So for example, if electrons are found in shell number 1, that's their ground state. If the electron is in shell number 4, that's the ground state. Okay. And when they gain energy, they become excited and they escape the surface of the metal. We will study more about this later on in the topic. The minimum frequency of light that can cause an electron to leave a surface, or the maximum frequency of light which excites an electron in the ground surface. Over here, you just have to use the definition that I mentioned to you.
Is it C? The minimum frequency of light that can cause electron to leave a surface.
Correct. Okay, after that, they're saying light of wavelength lambda traveling at speed c. Speed c is speed of light, is incident on a metal surface. Photoelectrons are emitted from the surface with maximum kinetic energy half mv square. The graph shows the relationship between 1 upon lambda and half mv square. So on the y-axis, they have plotted 1 upon lambda, and on the x-axis, they have plotted half mv square. Which of the following shows how the gradient of the graph can be used to determine the Planck constant? So you have to figure out that if you want to find the Planck constant, how can you figure out what will be the value of Planck's constant? Is Planck constant reciprocal of the gradient? Is the Planck constant 1 upon speed of light multiplied by gradient? Is it directly equal to gradient? What are we going to do over here? So, okay, I'm going to ask you a question. Laiba, in our last class, I went over a graph with you. On the graph, do you remember what I had told you was on the x-axis and what was on the y-axis? Do you remember what it was?
On the y-axis was the energy, and on the x was the frequency.
Yes. So half mv square was on the y-axis and frequency was on the x-axis. Now, and in that case, I had told you that gradient of the line is equals to Planck constant. So this is similar to that, but it's slightly changed. We have kinetic energy has now been shifted to the x-axis and 1 upon lambda is on the y-axis. So my question to you is this. First of all, let's see how can we relate 1 upon lambda with frequency. We know v is equals to f lambda. The speed of light is c. So c is equals to f lambda. So C upon lambda is equals to frequency. Okay. If you take the speed of light and you divide it by the wavelength, that will be equal to frequency. Okay. So, um, so your frequency is equals to C upon lambda. Okay. Now, so this is the same graph. This is exactly the same graph, but they have just taken the frequency, but instead of writing down frequency as f, they have related it to this concept, right? That c is equals to f lambda. So c divided by lambda becomes frequency, okay? So if we take c common, then 1 upon lambda is basically where the 1 upon, this is where the 1 upon lambda is coming from. Okay. So now we have to figure out the concept of Planck constant, right? So if you remember in the original graph, I had told you gradient is directly equal to Planck constant. Now over here, it's going to be opposite, right? How is it going to be opposite? Because kinetic energy is on the kinetic energy is where? Kinetic energy is going to be on the x-axis and this is on the y-axis. So, so, we have this 1 upon lambda. Now, think about it for 1 second, right? Take your time. Think about it. I have given you all the information that you need to solve the question, right? This graph is exactly similar to the graph I taught you in class. The difference is that they have changed the x-axis and the y-axis. And I told you as well that this 1 upon lambda, where is it coming from? It's simply the equation v is equals to f lambda and they've rearranged it. So using all this information, Laiba, give it a try. What do you think? That in the original graph, the gradient was equals to Planck constant. In this graph, how will you find the Planck constant using the gradient of the line? You can also use a trick like this. Gradient is equals to y upon x, right? Like whenever in mathematics we're finding the gradient, we always do y upon x. Y upon x is what? Y upon x which is rise over run, right? That's pure P2 in mathematics. Y2 minus Y1 divided by X2 minus X1. So Y upon X, the gradient is Y upon X. So in this graph, I had told you gradient is equals to Planck constant. So on the y-axis, we have kinetic energy, and on the x-axis, we have frequency. So I just showed you that frequency is equals to c upon lambda. Okay, so the gradient of the line is equals to, this is what Planck constant is equals to. Planck constant is equals to gradient of the line. So that is equals to kinetic energy divided by speed of light divided by wavelength. Okay, now you can then find the equation for this graph, the gradient of this graph. If you have to find the gradient of this graph, then in that case, the gradient of this graph is going to be, once again, y over x. On the y, we have 1 upon lambda, and over here we have high half mv square, or let's write it down as kinetic energy. So Planck constant is equals to kinetic energy divided by c upon lambda. So you can also use this concept to try to figure out how you can calculate the Planck constant using this graph. This one is slightly tricky. So try it. I know this is a bit of a tricky question, but give it a try and see if you can figure it out. If you want, you can even break this down even further. You can do c 1 upon lambda. Yeah, Labagwan, you were saying something?
Yeah, I was saying if you could explain this question.
Yeah, I will explain this question. Okay, hold on. So, do you understand what I was explaining to you so far? Like so far, does it make sense? Or do you want me to go over the initial part again?
Could you go over it again?
Yeah, okay, look. If you remember from our class, okay? In the class, we had kinetic energy on the x-axis and we had frequency on the y-axis. And if you remember, Laiba, I had told you that if you want to find the Planck constant, then just calculate the gradient of the graph. Okay? Now, this graph is the same as this one, but they have just changed the x-axis and the y-axis. So instead of the kinetic energy being on the x-axis, the kinetic energy, instead of the kinetic energy being on the y-axis, it is now on the x-axis, right? And on the x-axis, the graph I taught you in class, we had frequency. Over here, we have wavelength. So first thing we do is that first of all, let's try to understand that where is the wavelength coming from. How is, because in the class, I taught you with frequency, but the examiners are asking you with wavelength. So we need to see the relationship so we can, solve the question further. So V is equals to F lambda. Okay. So velocity over here is c. Speed of light is c. F lambda. So frequency is equals to c upon lambda, or we can take the c out, like I can take the c out as common, and we get 1 upon lambda, right? C multiplied by 1 upon lambda is the same thing. You get c upon lambda. So we can see that frequency is equals to, so that's the first point. Frequency is equals to C divided by 1 upon lambda. Okay. Now, the gradient, let's start with discussing over here. I had told you that gradient of the line is equals to Planck constant. If I give you this graph, this one, the first one, okay? If I give you the first graph, this one, the one I taught you in the class, and I said to you, Laiba, can you tell me the gradient of the graph? You would say, Miss, all right, no problem. To calculate the gradient of the graph, we do y upon x, right? The values on the y-axis divided by values of the x-axis. So on the y-axis, we have kinetic energy, and on the x-axis, we have frequency. Now, we just saw that frequency is equals to C divided multiplied by 1 upon lambda. So let's replace that. C multiplied by 1 upon lambda. So if I say to you, Liber, please calculate the gradient of the graph, you would do y-axis divided by x-axis, right? That's what we studied in mathematics. So on the y-axis, there is kinetic energy. On the x-axis, that is frequency. If we turn that into wavelength, so it becomes c multiplied by 1 upon wavelength. So this is equal to the Planck constant, right? Because gradient is equals to h. So h is equals to kinetic energy divided by c multiplied by 1 upon wavelength, right? Now, this gradient that we were talking about was the gradient of this graph. Let's talk about the gradient of the graph the examiners gave us. From the gradient of the graph the examiners gave us, from the gradient of the graph that the examiners gave us, again, to find the gradient of the graph that the examiners gave us, we can do y over x. On the y-axis, we have 1 upon lambda. On the x-axis, we have kinetic energy. Can you see the link? Your Planck constant is equals to kinetic energy divided by C multiplied by 1 upon lambda. If we look at the second graph, in the second graph, we can see that the gradient of the graph is equals to wavelength 1 upon wavelength divided by kinetic energy. Can you see that they're both opposites of each other? Both of these equations are opposites of each other, right? I'm going to write down the equation for the Planck constant again, but I will take out the C. I will put the C separately. See, kinetic energy divided by 1 upon wavelength. This is from the graph that I taught you in class. The graph that the examiners have given us, the gradient of this graph is 1 upon lambda divided by kinetic energy. Both of these are coming opposite to each other, meaning that that means that, what does this mean? This means that this, if I want to take, they're both reciprocals of each other, right? So if I want to convert grade, if I want to convert 1 upon lambda divided by kinetic energy, if I want to convert it into this, because we want to find the value for Planck constant. So if I want to convert it into this, I will have to do reciprocal of gradient, right? This kinetic energy divided by 1 upon lambda, that is 1 upon gradient, because they're both opposites of each other. So if I do 1 upon gradient, I will get the same thing, kinetic energy divided by 1 upon lambda. So Planck constant is equals to 1 upon gradient multiplied by C. So correct answer is option B. Right, Leba, is this making sense? Do you want me to go over it again?
Yeah, Miss, I got it.
Perfect, good. All right, let me share with you your next question. 1 second. Okay. In the second half of the 19th century, scientists begin to investigate interactions between photons and electrons. A discharge tube is a glass tube containing gas as shown. When the discharge tube is connected into an electrical circuit, the gas atoms emit photons. The photons have specific frequency. One of the emitted photons has a frequency of 3.44 into 10 raised to the power of negative 19. Calculate the frequency of this photon. Okay, so your examiners have provided you with the energy, but you have no other information available. The only option you have is the energy. Using the energy, you have to calculate the frequency. You just have to apply one simple formula. This question is only for 2 marks. It's very simple. So go through the formulas I taught you, choose the correct formula and calculate the frequency.
Miss, I got 5.19 times 10 to the power 14.
5 point?
19,
Yeah, into 10 raised to the power of?
14.
Yes, 14. Absolutely correct. Good job. Okay. Now, forget part two. Part two, I'm going to teach you about later. Take a look at this one. Photons with energy of 4.75 electron volts. So notice over here, Laiba, the unit is different. It is electron volts. It's not joules. So please remember, we have to convert electron volt into joules. Photons with energy 4.75 electron volts are incident on the metal surface. These photons cause electrons to be emitted from the metal surface. Show that the maximum speed of the emitted electrons is about 5.3 into 10 is to the power of 5 meters per second. So what do you have? You have been given the energy. You have been given the work function. You need to calculate velocity. In this formula, in this question, you will have to apply two formulas. The first formula the first formula involves energy and work function. And once, okay, so actually, just figuring out the first step is slightly tricky. Once you figure out the first step, finding the velocity is very easy. You will have no problem with it. So can you think of how we can solve the question? You have to find the velocity. Can you find something like something else, not directly velocity? Can you find something else that will help us calculate velocity?
Miss, I got 8.23 times 10 to the power negative 6.
To the power of negative 6. Okay. Can I ask how you're solving the question?
I use the equation E equals to work function plus kinetic energy.
Correct, correct. Did you convert the electron volts into joules?
No.
I think that's where you're getting the incorrect answer. You have to convert the electron volts into joules. Because if the formula you're using is fine, you have to use E is equals to work function plus kinetic energy, calculate the kinetic energy and get the velocity. But the I think the reason your answer, because your method is fine. So your answer is probably incorrect because you have not converted the electron volts into joules. To convert electron volts into joules, you multiply it by the charge of one electron. The charge of one electron is 1.6 into 10 raised to the power of negative 19. Also, when you are going to use the formula half mv square, so what mass are you going to use, Laiba? Do you know which mass to use over here when we use half mv square?
Miss, I was confused in that, but I used 5.3 times 10 to the power 5.
No, no, no. Okay. That is the speed we have to show. This is what the examiners are saying. Show that the speed is 5.3 into 10 is to the power of 5. So this is the answer we are supposed to get. Your answer is supposed to come 5.3 into 10 is to the power of 5. Okay, this is your answer. Your answer needs to come like this, somewhere around here. The mass, okay. So, Laiba, see, the question is about electrons. So we will use the mass of electron. Okay. The mass of electron, the charge of electron, all of these information are usually given over here. 1 second. Right over here. At the end of your paper, here you go. See, all the values are all given towards the end of your paper. So you don't have to learn these values, right? See, the charge of an electron. This is the charge of an electron. The mass of an electron, it's given over here. Okay. So the value of Planck constant as well, don't have to learn it. It's given. These values are given to you. So all you have to do, Laiba, is this, that you are going to use this mass, the mass of an electron, because you have to find the speed of an electron. So whose mass will you use? You will use the mass of an electron. So this will be your mass, 9.11 into 10 is to the power of negative 31. Okay, this is the mass. And the that is one mistake that you're making. Okay, that's the first mistake I think that you're making, that you're using the incorrect mass. So you have to use the mass of electrons. Masses of electrons, these kind of informations are often mentioned in your data sheet in the exam paper, last paper of the paper. And this is a mistake that students often make, that they don't know the information is given in the exam paper in the data sheet, so they get confused that what do we do. So often, consult your data sheet. So you will get the mass of electrons from your question paper. Then, so that's the mass you will use, the mass of the electron. Then the second mistake you're making is not converting electron volts into volts. You have to convert electron volts into joules. Okay, so how can you do that? By multiplying with the charge of one electron, which is 1.6 into 10 is to the power of negative 19. That is also given in the data sheet. You don't have to learn it. And then this should be your final answer, because we have to show that the maximum speed is this much. So your answer should be coming this much. Okay, so give it another try and see if you get the same answer, because your methodology, the formulas you're using are completely correct. So this is where I think you might be going wrong. So give it another try and see if you get this answer.
Miss, now I go at 5.35 times 10 to the power 5.
Yes, good. Now your answer is correct. Good job. Well done. Okay. So now you have realized two things, that one, whenever energy is given in electron volts, you need to convert it into joules. And secondly, that because in this topic, in photons and all, you are often dealing with electrons. So you have to just be really careful that the mass that you use is the mass of the electrons. Okay. Give me 1 second. Let me share the next question. Hold on. Okay. Hold on, in fact, just give me 1 second. Okay, a camera includes a five-sided glass prism. The diagram shows a ray of light incident on the prism at surface X. This is surface X, this one. This one is surface X. So you can see that the air light goes from less dense medium to more dense medium, so it bends towards the normal. The ray of light is then transmitted to surface Y. Explain why the ray of light refracts at surface X. Why is the light refracting? You simply have to explain the concept of refraction that I had taught you in the class.
Miss, is it because air is less dense than glass? Therefore,
Yes,
when the light travels from the less dense to the more dense, it bends towards the
yes.
normal.
Yes, but you just have to explain why is it refracting. So if you remember, I mentioned to you about how the speed of the light changes, and then that is the reason why the direction of the wave changes, remember? So you have to explain it, try to explain it using those words. So you can say over here that as the light travels from air to glass, or from less dense medium to more dense medium, the speed of light changes. This causes the wavelength to change, right? The speed of light decreases. This decreases the wavelength, and that changes the direction of the light, so the light will bend. Okay. So if you, whenever you're asked about refraction, try to explain it more using the concept of speed of light. The speed of light is the main reason. So speed of light is changing, that changes the wavelength. When it changes the wavelength, it causes the wave to bend. So that's why the ray is going to refract. Okay. Next, they're saying to you, at surface Y, the ray of light must be reflected. Okay. So when it's reaching surface Y, they're saying it will not refract. They're not saying it is going to refract. They're saying it is actually going to they're not saying that it will refract, they're saying that it is actually going to reflect. What is this principle called, Diabet? You remember when the light goes from more dense to less dense and it does not refract, instead it reflects.
Total internal reflection.
Yes, total internal reflection. So that is what you're going. That is what is basically happening over here. So the question is about total internal reflection. Now, they're saying, so basically they're saying that at surface Y, the ray of light must be reflected. This reflection could be due to total internal reflection. If the ray of light is not totally internally reflected, the light can be made to reflect by applying a layer of silver to surface Y. So they're saying that if the light is not reflected back, then we can sort of use a shortcut where we can apply a layer of silver over here. So that layer of silver will help in the total internal reflection. Deduce whether a layer of silver is needed on surface Y. The refractive index of glass used to make the prism is 1.52. So you have to figure out basically over here, Laiba, is the total internal reflection going to happen in the prism or not? If the total internal reflection will happen, then we don't need to use any silver. If it will not happen, then silver will be required. So you have been given the refractive index of glass. What is the information you have? You have the angle, okay? You have the angle of refraction, which is 50, angle of incidence actually, I should say. You have the angle of incidence, which is 53, and you have the refractive index, which is 1.52. You have to figure out if total internal reflection will happen or not. How can you figure out if total internal reflection will happen or not? What do you think? What is the one thing that you should find to figure out if total internal reflection will happen or not?
The critical angle.
Critical angle. So that is step number one. Step number one is you find the critical angle. Okay. What formula can you use? Look at the information given. What formula can we use to find the critical angle?
Are we going to use refractive index equals to 1 over sine critical?
Sin C. Yes, correct. Good. So use that formula and see if you can figure out, what the angle of refraction should be. Did you figure out what the critical angle will be, Laiba?
No, miss, I didn't. I'm trying.
You just have to use the same formula. You told me the formula, right? N is equals to 1 over sine C. So just use that and tell me what formula are you getting for the critical angle.
Miss, I got 37.7.
As the critical angle?
Yeah.
Okay, 1 second. So we will do sine C is equals to 1 upon n. So sine C is equals to 1 divided by 1.52. So 1 divided by 1.52 gives us 0.657, whatever. Whatever answer you get, you will do sine inverse. So when I'm doing sine inverse, my answer is coming 41.14 degrees. This is what I'm getting as the critical angle. Try it again and see if you get the same angle, 41.4. Are you getting this? You should get 41.41 divided by 1.52 and then you sine inverse the answer. So you'll get 41.14 for critical angle. So this is step one. Step one is to find the critical angle. Now you need to find the angle of refraction. Once you found the angle of refraction, so you can easily figure out if total internal reflection will happen or not, right? Because if the refractive angle is greater than critical angle, total internal reflection will happen. If not, the total internal reflection will not happen. So now, Laiba, think about it. You have the refractive index and you have the angle of incidence. Can you think of any formula that will allow me to calculate the angle of refraction? Using the angle of incidence and using the refractive index. Can you tell me a formula for the angle of that I can use to find the angle of refraction?
Miss, is it n equals to sine incidence angle of incidence over angle of the
Yes,
sine
yes.
angle of
N is equals to, yeah, N is equals to sine I over sine R. So using this formula, you will find the angle of refraction. Okay. So sine I is 53. Sine 53 divided by N. Okay, you will do sine I because you have to find R. So sine I divided by N is equals to sine R. So sine I divided by 1.52, and then whatever answer you get, you will do sine inverse of it. So your refractive angle is going to come out as 31.7. So you can clearly see, Laiba, the refractive angle is 31.7. The critical angle is 41.4. Do you think total internal reflection is going to happen?
Yes.
Think about it. For total internal reflection to happen, does the angle of refraction need to be larger or lesser than the critical angle?
No, there wouldn't be.
Yes, because the angle of refraction has to be greater than the critical angle, right? So our angle of refraction is smaller, it's 31. The angle of critical angle is 41. So if it was greater than 41, then we would see total internal reflection, right? But over here, the angle of refraction is lesser than the critical angle. So total internal reflection will not take place. So what are we going to write in the exam question? We're going to write down, they said deduce whether a layer of silver is needed. So yes, a layer of silver is needed because without it, because otherwise total internal reflection will not happen. Okay. So the steps of what were the steps? The steps were that first you find the critical angle, then you find the angle of refraction, and then you figure out which one is bigger and if total internal reflection will happen or not. So it will not happen. That's it. Your question is now solved, and it was for 4 marks. So it was a relatively simpler question. Right, Laiba? Making sense, right? No confusion so far?
Yes, there's no confusion.
Okay, all right. Okay, Laiba, then we'll go ahead and stop it over here for today. And in the next class, we're going to continue with practicing our questions. Okay?
Okay.
All right, Laiba, have a good day. I'll see you in the next class. Bye.
You too, Miss.